Trust me. Everything's gonna be fine.
Gentlemen, welcome to Math School. In this video, we shall be talking about equation of a line. In fact, obviously, one video is not enough to cover the complete chapter, so we'll have to focus on one complete series. This video will focus only on the basics and all the important things that are necessary for you to understand the concept properly. Solving will not be happening in this video. Only understanding the concept will be focused on. So any question based on equation of a line, there'll be a lot of repeat words. For example, slope, inclination, coordinates, and all these things. So let's try to understand the meaning of all these things. So let's dive with the first case. It says when inclination is given. In other language, inclination, simple language, means angle. So angle in this specific chapter is always calculated with respect to the x-axis, always. Okay, so let me draw one thing. This is the reference x-axis. It has to be a straight line, but obviously it's not straight enough. Then let's say this is your equation of a line which you're trying to find. Fine. So it's going in this direction. So with reference to the x-axis, where it is forming an angle, and the angle is always calculated in the anti-clockwise direction. Fine. Now, if you ask me what happens if it is clockwise direction, then the angle will be considered to be negative. Any positive angle should always be in the anti-clockwise direction. So now I'll mark this to be theta. Fine. So theta is being marked. So that specific thing is nothing but inclination. So let's say in your question, some random angle like 45 degree, 60 degree, 75 degree, all these things, wherever degree is being given. And most importantly, the meaning of slope, we'll talk about a little later. The concept of slope will always be represented by one letter called as m. And m should always be in lowercase. And let's say you're supposed to find m when theta is given. I'll repeat that. To find m when theta is given, theta meaning inclination, you will stick on to one formula called as m equals tan theta, where theta is always the inclination calculated in the anti-clockwise direction. If something is in the clockwise direction, then we're supposed to consider it to be negative. Keep this in mind. So this is your first form to find slope. Again, to find slope, we have another form. And this time, it does not depend on theta. It depends on coordinates. Obviously, you guys know points, and each point will have two coordinates. As you guys can see here, you'll be able to find the value of m when 2 points are given to us directly. x1, y1, x2, y2. Now, how do you find? We represent m first. We write slope on the left hand side equals. Always understand the second things will come on top. The second things. In other language, the second coordinate, also called as the y coordinate, will be on top. Now, currently, if you guys can observe properly, we have two y coordinates. What are they? y1 as well as y2. So it's always y2 minus y1 by x2 minus x1. So to recap, we have two cases in order to find the value of slope. One is when theta is given to us, and one is when points are given to us. Are both of them same? Left hand side is the same, obviously. So right hand side keeps on changing from pattern to pattern and question to question. Careful, if I ask you find the value of slope for some random angle, let's say 60 degrees, then you cannot use case number 2. You have no choice there. It's only case number 1 you're supposed to use. But if I tell you 2 points are lying on the line, find the slope of that specific line, you will still be able to find the answer using what? M equals y2 minus y1 by x2 minus x2. Things to keep in mind: y2 minus y1 will always come on top. It's always called as difference of the ordinates by difference of the abscissa. Abscissa ordinates rings a bell. Somewhere in your lower grades would have learnt it. X coordinate, y coordinate also have different names. So we'll keep this in mind. So two forms for slopes. Now we'll move on. Now I could based on these two forms, I could have started with a question, but not required. We'll deal with some special results right now. In fact, there are 4. Now, there can be infinite actually, but I'm talking about your 10th standard syllabus. These 4 are good enough for you to score full in this specific chapter, okay? And I think the most important thing in this specific chapter, more than the concept, is understanding the question, which means your English, okay? You're supposed to know when exactly to use the word parallel, when exactly they're using the word perpendicular, and what's the meaning of it, because each and every word in this specific chapter carries a special meaning, okay? That's what we'll be talking about. So 4 special results. The result 1 is right in front of you. It says when lines are parallel to each other. See guys, the whole concept of parallel is they do not meet each other. Correct. Fine. That's absolutely fine. But if you think of them in terms of theta, don't you think both the lines will have the same angle? Two lines which are parallel, which obviously, best example is railway track. If the angle changes of one line, what happens? Then they cannot be parallel to each other. I'll draw one set of line. Listen up. One line and one more line. if you guys can see little extension here, they'll meet, because the angle of both of them with respect to one of the axes was not the same. So it's very important for us to understand parallel lines. Yeah, they do not meet each other, but end of the day, the angle is the same. Now understand, I'm stressing on the word angle, which means if I write theta 1 equals theta 2, don't you think automatically m1 will be given by tan theta 1? Obviously, m2 will be equal to tan theta 2. So since theta 1 is equal to theta 2, don't you think automatically m1 will also be equal to m2? So that's your first special result. When one set of parallel lines are given, the slopes of them are equal. I'll repeat that. When a set of parallel lines are given, the slopes of the lines are equal. So next time you guys see, you can directly write m1 equals m2. Fine. For what? For parallel. Now what happens if it is perpendicular? Look at this. If it is perpendicular, again there are two lines. Both the lines, and most important thing here, look at a first angle called as theta here. It is calculated in the anti-clockwise direction. If you look at alpha here, it is calculated in the clockwise direction, which means alpha in this case will be negative. Okay, because it's going in the opposite direction. Should we talk about that right now? Not required. I'm just trying to tell you. I wrote that specific angle to tell you that angles can also be negative. Okay. Now, how do we solve that? Not required in this specific case. I'll solve that when we actually deal with the question. But since there's a special result, I'll only talk about the word perpendicular. If it was parallel, if slopes are equal, if it is perpendicular, understand the product of the slopes. Slopes of what? Lines. So two lines will be having two different slopes. Line 1 will be having m1, line 2 will be having m2. Okay. The product of the slopes will always be equal to -1. This is the result. I'll repeat that. Product of the slopes will be equal to -1. If it is perpendicular. If it is parallel, both the slopes will be equal. In simple language, m1 will be equal to m2. Both of them are very, very, very important. I'm not trying to promise you anything, but almost every other question, either one of them will be using. Okay. See guys, the concept from equation of a line, also called as straight lines, you'll be getting a lot of sub questions. So one main question, multiple sub questions. So you'll have to be in a state to understand that all the results will be used here, all the results. So depending on which sub question we're trying to do. Okay, cool. Now results are done. Next, result number 3 is when lines are parallel, but this time it is with respect to x-axis. Now with respect to x-axis meaning, see, understand here, theta is always equal to 0. That's the whole point. X-axis meaning theta will be equal to 0. So both the lines will have the same slopes. Why? Because they are parallel. But since they are parallel to x-axis, the value of theta will be equal to 0. So let's write here. So if m equals tan theta, it becomes m equals tan 0. What's the value of tan 0? 0. So slope of any line parallel to the x-axis, I'll repeat that. Slope of any line parallel to the x-axis, the answer will always be equal to 0. Fine. Now if you ask me, so what about line 1 or line 2? Both of them are parallel, no? So in simple language, m1 equals m2 equals 0. That's my third special result. Now where will this be asked? Most probably MCQs. Okay. So the final result, it says when lines are parallel to y-axis. Lovely. See guys, common sense, it is parallel to y-axis, but if you think in terms of x-axis, don't you think both of them are perpendicular here? Fine. Which means if I consider this to be line 1 and line 2, the angles are same. m1 will be equal to m2. Done. Because they are parallel to y-axis. Done. The angle between them is also same. Theta equals 90. So m will be equal to tan 90. Tan 90 is nothing but infinity or not defined. So m1 equals m2 is equal to infinity. So in simple language, even when a set of lines are parallel to y-axis, the value of the slopes are not defined. Okay, so these 4 results will be asked in terms of MCQs, will be asked in terms of questions. Result 1, result 2, very important for all the questions. Result 3, result 4, most important for 1 markers. So to continue we'll continue with the video series. The next video will be talking about specific questions.
The first rule of Fight Club is
subscribe.